We are moving on to the last session. You know, is last but not least. It's a session on Session D, applications of ICT tools, information and communication technology tools. We have 5 presentations. And the first one is faculty perceptions and usage of generative AI in Geotechnical Engineering Education by Salifu, Cuccurullo, Muguda. Is that correct? Okay, from US, Belgium, and UK. Okay, thank you.
Okay, so hello everyone. I am Alessia Cuccurullo from Université Libre de Bruxelles in Belgium. I'm very glad to be here today to present this work, also on behalf of my colleagues, Emmanuel Salifu from Arizona State University, USA, and Sravan Muguda from Durham University, UK. So our study is about faculty perception and usage of generative AI in geotechnical engineering education. So let me begin just by setting the context, and let's begin with the definition of what's artificial intelligence and AI. So according to Google, so AI refers to all the technologies, okay, that actually enable machine to perform complex tasks. For example, language understanding, analysis of data, but also language understanding, which usually require human intelligence. Now, so far with the development of machine learning, we actually have trained algorithms to interpret data, to analyze data, but with generative AI, we are actually on the next level because we are actually making original content. So let's have a look a little bit about what research has to say about the use of generative AI. So to begin, there is a big part of research that actually has a tendency to highlight the generative AI ability to actually enhance the learning, but also the teaching experience. So what is that about? So people feel that these tools can actually be used to improve the quality of our images, the quality of our learning materials, slides, syllabus, notes, whatever we actually give to the students to actually learn. Another part of people actually use these tools for administrative tasks, to help the translation of some documents, to answer emails, whatever, just to speed up also the grading of some students' assignments, etc. So, general feeling, generative AI tools are actually a very powerful teaching assistant. But there is another side of the story, and there is a huge part of research that actually have concern. Especially they fear the fact that actually students can rely too much on the use of generative AI tools, missing out on that cognitive effort that actually is required to deeply engage with the learning material. Other concern, accuracy, academic integrity, plagiarism, okay? Or also the authenticity of the student work. If they can use generative AI tools, how we can actually evaluate them properly. So there is not a unique perception on generative AI tools, and I think this is clear, and this is like the motivation behind our study. So what we did, we actually circulated a survey across our academic colleagues to better understand what was the perception, but also their usage of generative AI tools. Let's first of all understand the public of the survey, okay? So we designed this survey, and actually we circulated it just across academics, okay? So this is really academic perception, not really the student perception of generative AI tools. We send actually the invitation to fill in the survey to everyone that actually had experience in teaching to students at undergraduate or postgraduate levels. So we have assistant professor, professor, associate professor, also technicians that they were invested in a laboratory session with students. It's a very diverse public in terms of gender, in terms of age, and actually we received an answer from 12 different countries. So we can also have a view of what is the different perception worldwide. Now, before digging into the result, just a few words about institution policies, okay? So while we were actually performing our study, we realized that looking at the UK institution, what they have done is actually they have embraced and they encourage the use of generative AI tools. They actually have included their use into their policies, okay? However, they always say responsible use, okay? So, when we look at American institutions, there is a little bit less consistency because there are some institutions that actually they have embraced and encouraged the use of generative AI tools, and they also created open AI spaces, but there are also other institutions such, for example, the Colorado State University that restrict and limit the use of generative AI tools to academics and students. Across Europe, we are aware that the generative AI tools exist, but we still didn't actually include the use of those tools into our policies. Now, what was interesting to discover in our study and looking at the result of the survey is that when we asked, do you know if at your institution there is a policy about the use of generative AI tools? Majority of the people we interviewed, they said, not really, I don't know, I'm not aware of it. So either they didn't know, or they actually never wondered about it, okay? So that was a first important result. Now, digging into more details, we actually were surprised to find out that 92% of the people that we interviewed, they didn't actually use generative AI tools at the moment of the survey, which was a few months ago. So they actually did not use those tools at all, which for me was surprising. I mean, I'm one that actually used those tools, so I was surprised. But it was interesting to actually see that 95% of the people that we interviewed, they had a strong interest in understanding better those tools and maybe use them in the nearly future. Okay, so the message was clear to us. There is interest, but academics need training, and especially they need a safe space to experiment, because one of the comments that we received was, yeah, I want to use them, but I'm very concerned about the privacy of those tools. So what I'm actually putting in, I don't know where it goes. So I think most of the people actually feel unsafe to use those tools. Then, another interesting result was that 63% of the people we interviewed, they actually found generative AI tools useful in assisting teaching, okay? So, a powerful teaching assistant tool again. However, we also asked, do you feel that generative AI tools are a threat for your role as a teacher? And 75% of the people we interviewed, they say, not really, or they didn't wonder so much about it. So that was another interesting result. And when we look at the current use of academics of generative AI tools, they use mostly to write their emails, to translate their documents, to actually have like a real-time, fast feedback on student work, and they use them in their academic writing, you know, just to improve clarity, the presentation, and they use it to improve the quality of the teaching slide, images, pictures, flowcharts, or those tasks, essentially. And then what we observed from the survey result is also that our public was very much concerned about the critical thinking that users might develop by using those generative AI tools. I cite here one of the participants to the survey. They say that using generative AI tools will spoil the creativity of the user. And this is like a concern that has like how many minutes? 1 minute, okay. This is actually a concern that has a fundamental, it's supported by research, because actually research is showing that using generative AI tools, we actually develop lower like neural activity and a lower like cognitive performance. Other concerns were about evolving our assessment methods, because how we can actually evaluate well our students when actually they can use those generative AI tools to solve the problem we give to them. So we have to also update our assessment methods. And about accuracy, I cite here one of the participants to the survey. He said that with the generative AI tools, we can actually make information but not knowledge. So I think that the feeling was that when using generative AI tools, so we have to be really critical, so we have to critically evaluate what we get from these generative tools and not accept the result as such. And another thing was about the urgency of experimenting and the need for guidelines, but being very careful on that, because there is like a constant progress on generative AI tools, so we might make guidelines today and already be outdated tomorrow, because there is like a constant, very fast progress. And then just to conclude, I would like just to say that what was our final thoughts. What were our final thoughts is that actually generative AI tools are here, okay, and actually they affect the teaching and learning experience. But our feeling was that the teachers, us as academics, we have a tendency to integrate, so use those tools to integrate our teaching methods, while the impression, like when we look at students, we had the feeling that the students have a tendency instead to replace their learning, conventional learning methods with those tools. And that's a dangerous path to take, and so we need immediate action on that. Last, this presentation has been generated by using ChatGPT, okay? The only input were the paper we wrote, the conference template, okay? And I just sent like an audio message saying, okay, I want to put my attention on this, this, and this, very fast. The ChatGPT took a few minutes to make this presentation, and I didn't actually work on it. My feeling, is that I could have done a better job, but if we do a balance on the time I needed to make this presentation, I still feel it's good quality. And up there, you can find the QR code and the link to our survey. We didn't have many participants to the survey, so if you can just participate to the survey as well, we would like to know your opinion, your perception, and it will really help our future research in this direction. Thank you.
Thank you very much indeed. Is there any question, any quick question? Yeah, Francesca.
Thank you for your presentation. I have a curiosity. When you reviewed, let's say, the literature on this topic, did you have the feeling that maybe these are not, let's say, super partes, but they get some pressure from companies producing AI, or on the other way? So what?
You mean like if the academics feel this pressure?
No, no. At the beginning, you showed some papers.
Yes.
You know, of course, there is a lot of discussion on that, but I was wondering if there are companies putting, you know, a bit of pressure on that to get positive.
I would say yes, definitely. However, like let's say that what I showed, it's really like it's not like what we find in the newspapers. It's research. Those are all articles, peer-reviewed articles. So
yeah, but we know that also in research sometimes there are
but I hope that
you
at
know,
least on that we can still at least have our freedom to investigate without that pressure.
Yeah, it was just
your
opinion on that.
Yes.
Okay, thank you very much. We're moving on to the next presentation. Thank you. Which is implementation of a blended learning strategy for geotechnical courses by Araújo Santos, Ribeirò, and Proença from Portugal.
Okay, so good afternoon, everyone. We are reaching the end of this conference, which has been very good, at least for me. I've been learning a lot. And I'm going to share a little bit an experience that we are currently implementing at the Polytechnic University of Coimbra. It is not new, it's flipped learning. We are using a common platform, but I think the idea is different. I'm working with my colleagues from the Science Institute of Douro, and also Sara Proença from the Polytechnic University of Coimbra. So I'm going to go through all these topics very quickly. So the introduction, why, how we started? Well, pandemic COVID-19 has had a huge effect on every one of us, of course. And we had to switch from one day to another to online classes. So the first approach was, okay, let's do business as usual, but we rapidly saw that it is possible. We have to find other ways to motivate the students. So we enhanced new platforms, and flipped learning using Moodle platform was one of the solutions that I used, and some colleagues of me also used to keep the students motivated to learning geotechnics. So a little background about flipped learning and blended learning. So we all use ICT in our lessons, so GEE, as we saw just now, presentations, videos, etc. So it's not new. And blended learning can help students, namely for those who don't have much time. For them, they are working students, for example, they cannot attend to the classes, so it can be an advantage for them to improve their performance. So the idea was to bring a balance between the online learning during COVID-19 and the face-to-face learning that is our core. So with flipped learning, we can engage students more. So we are centering the focus on themselves. So they are learning by themselves, and we are not teaching. Of course, we are teaching the curricula, but they are focused on learning, not only to listening or to seeing or taking photographs of the whiteboard at the end of the lesson. So we are moving to this, what you call the active learning methodologies. By using a learning management system platform, which in this case is Moodle. It's a free platform, it's a very nice platform. We already have it at our school, but it is used as a sharing platform, so as Google Drive or Dropbox or what else. So we are not using the platform as it was supposed to be used, only to share information and upload some documents time to time. So the idea is to bring everything together and to make a project that we call it Geotechnics at Home projects. And this idea is not to replace the web page of each course. So in our case, we have 4 courses in the undergraduate. So we have Introduction to Geotechnics, Soil Mechanics, and Foundation 1 and 2. These 4 courses will keep their web pages in Moodle platform. The idea is to create an umbrella web pages where all this information can be there. So the teacher can use it or not to implement flipped learning if the teacher wants. And also the students can, if he has any doubt in the last year, for example, I have a doubt about soil classification. He can go to this platform and to have some revisions about what he learned some years ago. So I think the innovation here is, okay, we have a platform that can be used as flipped learning methodology, or a platform just where all the information is there, and the student can revise not only by reading or that it is supposed to be used to do, but by redoing exercise, redoing evaluation test in a blended learning solution. So about the platform, it was designed to think about blended learning methodologies. So we have a welcome page okay, where students have to engage themselves, so they have to present themselves, they have to learn how to use the platform, how to go backwards, forwards, how to upload documents, what is the timetable, what are the summary attendances for the course. In this case, it was for soil mechanics. I used this as a flipped learning methodology, so the students had to use the platform during all the courses. So they have to upload a short bio of themselves, they have to answer to their colleagues, they have to do some posts. It was mandatory for them, okay? Otherwise, they are not, the completion status was not assigned as done. So they have to do all this process. Then we have a small lecture to start their courses. In this case, I choose the PISA lecture from Professor Bolland. I think it's a nice lecture for them to see what we can do in geotechnics, what are the challenges we have to face, and what are the solutions. So I think it was a very nice video to start. And then they are fully immersed in the platform. So after that, we have, of course, a student's corner for attendances, for summaries. That is important for them to know where they are and where they should be, if you are in time with the idea of the professor or if you are late. So I think it's important. Also a cyber cafe for them to ask some questions, not only related to soil mechanics, but other type of questions, a kind of chats. I think it's important for them to have this kind of atmosphere that they are all friends. They can speak together about the course or about anything else, and of course the Geo help about doubts regarding the course itself. All the lectures have more or less the same appearance. So they have a lecture on the topic. The lecture is based on videos that we have made, most of them during the pandemic. So we are reusing this material. Of course, we are redoing the video because the first videos were too long, with 30 minutes, 40 minutes. So we have to short them in 10, 12, 15 minutes. So it's an ongoing project yet. Then we have, of course, a forum for questions for the students dedicated to this topic. And then you have the self-evaluation part that I'm going to speak about it in 1 or 2 slides. There is no hierarchy between the lectures, so the students can choose by which lessons he wants. Of course, if the teacher is speaking about soil classification, he's going to read about this or to listen about this, but he can start with granulometry or by the limits, so he can start wherever he wants. Okay, that's another things that we think if the students want to use the platform as a revision. For revision, he is not going to be obliged to start in chapter 1 until reaching chapter 3, for example. So he can just move forward as he wants. So that's, I think, is good for both methodology. And then, of course, we have all the completion systems for them to force them to go until the end of the lecture. About the evaluation, that depends, once again, of it is being used for flipped learning or not. If it uses it, we implemented at least 2 self-evaluation. The first one, it worked as a self-evaluation for the students to know how is the study, if it is prepared, if not. So you're going to receive feedback of the teacher that is teaching the course. And then a second self-evaluation test that will be graded and used as grade in the final of the course. Once again, if the platform is not used as flipped learning, the students can't attend how many times he wants the self-evaluation test. But the idea is not for him to learn by mistakes, okay? It's for him or her to know, okay, what I know less or better in order to focus their study in this part of the curricula. About the students' performance, I have here the last 6 years. I didn't put the COVID year because it was different, of course. And if you look to the first column, the 23-24 academic year, we can see that the results increase in average, but most of the maximum and minimum results, what I enjoyed the most is that the amplitude between the better grades and lower grades decrease, which means that not only the best students, if you call like this, have better results, but also the other students can improve their performance by using this kind of technology. So I think it is a great news it was a great news for me and my colleagues. So as final conclusions, it's an ongoing project. We have a lot to do, a lot to implement, but we are having good results. This year is ending, so in the next time I'll have more information about what happened this year. But as next intervention in the platform, we want to introduce gamifications for the students who like gamification with experience bonds, for example, and also use other type of platforms, hypotheses, video ends, to try to have more interactive lectures or videos, not only to read and to see. So I have more interesting things to do for students. So thank you very much for your attention.
Thank you very much. Is there any question? Yeah, Michele.
Hi, thank you for your presentation. Is it open to people from outside your university, or is it?
No, it's as it is the school platform. Only students registered with the email of the school can access it. It's one problem for now.
Yeah, okay.
For now.
Then that's it. Thank you. Okay.
Sorry, can you expand shortly what you do for the flipped classroom? So what you are asking the student to do before the face-to-face meeting? Asking to address a specific topic, ask to solve a problem, and they manage what they would like to do, or you are asking them to watch video lectures and then you go to the class?
So that depends on the topic. For example, about soil classification, what I ask them is to see all the videos and read all through the material. When they arrive at the classroom, I say, okay, we have this soil, and the idea is to classify the soil. So you have to do the lab tests, or you have to solve some exercises, okay? You have to do it. And I'm here just to help you and not to teach you. If you have any doubts, just go again to the videos. That is to learn to read the standards for themselves, to understand the standards. Then they have a doubt, I will explain them.
The video is still made by you, right?
Yes,
yes.
yes,
Okay,
yes, yes. Okay.
Yeah.
For the self-assessment, how is that carried out? They do it at home by themselves?
Yes, yes. So all the assessment, okay, now with
exactly,
yes,
yeah,
exactly.
That's why I was asking.
Yes, that's a good point. What we do is to reduce the amount of time they have to answer the question. So they can go look for the answer in the internet, of course, but they're going to lose time to answer all the questions. So by the end of the test, they will answer probably good to 10 questions, but the other 10, they didn't have time to answer it. So it is what we do. It's not the best solution for now.
Yeah.
We have another solution that is the safe browser, for example, to integrate it in Moodle.
They can have two computers.
Yes. So there's no...
Why I'm asking, because
yes.
I'm teaching another unit called Risk Reliability and Safety, and I'm also teaching in flip mode, that unit as well, and I had students that were face-to-face and then students that could be online because they are working. And what I was getting at final exam, so for the final exam, I was writing an original case study. So it's something that, is not available anywhere else. And then the questions for the exam were based on that case study using the theory that I have taught them throughout the semester. The online students, once ChatGPT got in, the online students became phenomenal. All of them were getting over 80%. So I had to say, there's no longer online classes. You're all coming to class for the exam. So this is why I'm asking, how do you solve this? Because I thought that I had bulletproof solution for ChatGPT, but it turned out that it's not.
What I intend to implement, as you saw yesterday, is about oral examinations. So they have to come in front of me. I have several questions, and they have to answer me in 15 minutes of these questions. So I have to improve it, of course, but yes. Thank you.
Okay, thank you very much. We are now moving on to the next presentations. There is a group from local people from Nancy. Next presentation is use of virtual reality for teaching geotechnics, application to the study of an abandoned underground mine. The deck from Nancy.
So I will present you today an original activity, pedagogical activity that I developed in here at Nancy in order to make possible for the student to realize geotechnical expertise of an old abandoned mine, underground mine. So to do this, we developed the activity with the use of a virtual model of the mine in order to make possible the visit. Yes. So this is a room and pillars mine. This means that you have pillars, sorry, you have pillars. You have pillars in order to support the overburden, but you have also some embankment in the mine, so on the left, which help also to support the overburden. And if you look at the roof, you can see that there are, it's not working, so you have many cracks at the roof, and some blocks may fall from the roof. So the question for the student is to be able to study both the local stability of the mine. This means if we want to secure the roof, what must be done? And the second question is about the global stability of the mine. So are the pillars strong enough to support the overburden? So the context of the studies is a practical activity, so the students have 3 hours to do the job, and after this, they have a personal additional time to write a report about this question. So this is for master degree students, and the group of students is about 5 students. So students have many documents to do the case study, and some of them at first are required to know where is the mine. So you can see that the mine is very close to a village. The mine is close also to a valley. And with the help of different documents, they can build very simple geological sections. So the mine is quite horizontal. The overburden is composed of limestone and marl. So this is an iron mine, and the depth of the mine is between 20 meters near the valley until 25 meters. So this is an old mine because the age of the mine is about 150 years old. So students have many documents, but not the most important, but what is original is that we have developed a virtual model to make possible the visit of the mine. So the virtual model is based on 80 stations, and for each station you have 360 degrees photographies. And you have also a 3D scan measurement which allows to know the position of every point around the station. So students may visit the mine by moving, by jumping from a station to another one, and they can look around. So you have the map of the mine on the left. The surface is about 1 hectare. And thanks to the 3D laser scanning, it's possible to, for example, to create an ISO value of the depth. And on the right-left picture, you can observe with the blue color an horizontal line, and so it can be observed that in the room, the roof seems to be lower than at the edge of the room. So this means that probably the roof is bending in the room. So students need to realize two analyses. So the first analysis is about the local stability. This means if you want to secure the mine, is it a probability of failure of a part of the roof? So there is one, because we can see in some part of the mine some materials that have fallen. But we need to understand what is the origin of all the cracks that can be seen in the roof. So to do this, we can use I don't know if it will work. Yes. We can use this map. So this map, and you have a zoom here, is given with 3D scanner measurement. So at first, so this is what the measurement give you for the roof. So at first, we can see something like a patchwork of white and black. So all this area with the patchwork means you are in the corridor or in the room, and every white part are embankment or pillars. And if you look carefully, you can observe that there are some alignments here. So it's obvious that there are some alignments, and these alignments maybe are continue over all the mine. So if we then think about this, we can prove that in fact we have all the signature of all cracks of the roof. So thanks to this, it's possible to do a map of all cracks at the roof, and to observe that we have, in fact, in this mine, three families, the red and the blue one with very parallel cracks, and a green one, which seems to be more random. Based on other documents, a student may observe that, in fact, the blue and red discontinuities are parallel to faults that are known in the vicinity of the mine. So we can consider that all red and blue cracks are quite natural, so there was existing before the exploitations, but the green one are probably cracks that are the consequence of the stress redistribution over the roof. So with this, students must decide how it's possible to secure the mine, and they must do the design of a reinforcement solution with bolts. The second part of the study is to assess the global stability of the mine. So the question is, are the pillars strong enough to support the overburden? And it can be observed with the model and with additional photographies that we give them. It can be observed that some pillars have vertical cracks, and in some embankments also we can observe vertical cracks. And these cracks, so students need to interpret these cracks and to understand that this is the signature of an overload of the pillar probably. So if we want to compute the safety factor of the mine, we need to use a simple model, the tributary area model. And in fact, we need to know what is the surface of the pillars compared to the surface of the void. So we have two possible assumptions. One is to consider that only pillars with rock mass, so this kind of pillars, may resist. In that case, we find a safety factor of 1.1. Second assumption is to consider that the embankments can also resist to support the overburden, and then we find a safety factor of 1.7. So the student need to deal with this and to suggest some conclusion. So what must we do with such a result? And if we need to secure the mine, what could be done? So to conclude, we test this model the first time this year with 4 groups of students. They said me that it was very interesting, very original, but a bit difficult and complex. So, okay. So my opinion is that first advantage of this model is to make possible something which is quite impossible, because the mine is not is far from the school, so we need a bus to move the student if we want to visit the mine. It's a bit dangerous also, so it's not so very safe to offer the possibility for the student to really visit the mine. For me, from a pedagogical point of view, it's very interesting to put the student in the position of an expert. So for them, it's a very new activity and new problem to be in this situation where, in fact, there is no exact solutions. we have no real answer. So, but we can together think about what seems to be the most probable and what could be done. And in order to if we want to succeed, we need to really guide the students. So we need to be with them in order to answer all their answers. So really, we are not here to lose them. We are here to guide them. And at the end of the 3 hours, they need to have all the materials to be able, alone, to achieve the work.
Is there any question?
Did you see anything about the funding of this in the presentation? Who funded this?
Who funded the site?
No, where did you get the money to do this?
Ah, founded. Okay. This is a call from the region for pedagogical activities. So the cost was about 10,000 euros to do the model, in fact. So we asked a company to do this. So this was the fund.
Here's one question from my side. But the software is a commercial software that you can use, or it's I mean, this is the cost of preparing the models or taking information with laser scanner and so on. But apart from that, you need a license for the software, maybe.
Yes, no, we need a license. Yes, you're right. Because in order to use the model, so the model can be seen on the website, but the company which offers the website asks an income, yes. Yeah. So the cost every year is about 500 euros.
That's not much. Okay. Okay. Thank you. Thank you very much indeed. Oh, sorry. Next presentation is from Abdallah, Cuisinier Masrouri, enhancing geotechnical site investigation and project-based education through virtual reality, the GeoSim experience.
Okay. My presentation will introduce a brand new application that we developed locally in order to enhance geotechnical site investigation in our engineering curriculum using light virtual reality technology. The application is called GeoSim. So just to recall the context, donc, here we have the representation of the entire curriculum of engineering at ENSG, sorry. The curriculum is organized in semesters. We have a three semester common core where fundamentals are given about geology, engineering geology, mathematics, mechanics, and engineering soft skills. Then the students choose a specialty, a major. For those who choose geotechnical engineering as a major, they have this list of courses here, the second year, and for the third year. So it's a classical curriculum of engineering, geotechnical engineering studying. The units that are in yellow are those where we need, when we help students to investigate sites for construction projects. So we need skills related to site investigation. And what we do in general is that we teach theoretical courses about site investigation, complemented by lab experiments, lab courses, and we organize visits to construction sites, relying on our industrial partners who provide access to some construction sites and give demonstrations on the main methods used for in situ testing, for example. But this is quite complicated because we are dependent on the availability and the access possibility to the construction site It's a little bit complicated to organize. We managed doing it, but in general, it's a little bit complicated. So the idea was to develop an application that could help our students to be immersed into a real-world project, a simulated real-world project, in order to conduct a site investigation project in autonomy. So this was the reason for which we tried to develop this tool. We responded to a call for proposals proposed by the University of Lorraine, who was selected for a national program funded by the French government called PEGGHy. So this program provided funding about a little bit more than 5 million euros to 17 selected institutions in order to develop application as digital transformation technology demonstrators. So we responded to the local call of the PEGGHy project, and our proposal were accepted, and we received the support, the full support from the team, the PEGGHy team, to help us develop the application from the design till the deployment and the use. The only condition was that the tool have to be shareable through Creative Commons license and made available for everyone. So the objective was to enhance teaching geotechnical site investigation, enrich the students' experience through an immersive technology, and provide also complementary learning resources in order to help students be autonomous on conducting the project. So what's important to say is that GeoSim currently is a prototype that needs to be enhanced and complemented with additional material in order to add functionalities. So first we selected a site, a real site. We chose an experimental farm, experimental domain, belonging to a neighboring engineering school in Saya, which is situated near Nancy. The project that we imagined concerns an extension, construction of a building that would be used for technical and administrative applications. And the project consists to construct the building at this location, this precise location, with the help of a consulting company, Geotech, which is a partner of our school. We defined a project with a drawing of structural elements, including load-bearing walls and columns of two types. We defined the loads, the design loads for the project. We conducted also some in-situ tests. Here you have an example of pressure meter tests and dynamic CPT tests. So what you can see is that on the site we have two layers. One clay silt layer of about 5 meters, and then a clay soil. So the definition of the scenario for the application, what you can see on the paper, on the conference paper, is this. So we decided to define, sorry, I'm not used with okay. So we defined a pathway. Here, what is in blue represents what is in virtual reality scene. And we imagined that we begin with a virtual meeting room when we explain the project, when we give the data, explain the tasks that we assign to the students. Then we can move to a virtual construction site, make a visit, take some measurements on the topography, etc. And then move into a Moodle LMS space where the students can download the test results they ordered. This scenario was a little bit complicated to conduct. We encountered some issues concerning the back-end tasks, given that the project is intended to be shareable, donc usable by everyone. And this back-end task needs intervention from us, from the faculty team here. So in order to solve this problem, we decided to change the scenario, putting all the process into 3 different VR scenes. First, virtual in situ testing scene here, then a virtual laboratory testing scene to provide additional learning resources for the students, and finally, a virtual construction site for designing the tests, the boreholes that the students will request. And we imagined a menu, a continuous menu, where the user can move into between the 3 scenes. So this was the schedule. Finally, what took a lot of time, in fact, was the shootings, organizing the shootings, and then editing and coding. So I had to put gentle pressure in order to be sure that the application will be presentable to the conference. And I really thank the team that did the work. The application is usable. You can see here some images, some videos in accelerated mode on the use of the application. So you have here the videos that remind the students, recall the principle of different testing methods. And here you have a video showing the selection of borehole positions on site. Oh, doesn't work. Okay, so some of you probably tested the application with the headset, with the VR headset, but you can also test it on the internet. It is available online. Thank you very much.
Very much for the presentation. Is there any question? Yeah, over there.
Thank you very much. Very impressive. I'm only asking for a friend. Would it be possible to get a different language subtitle?
Yeah.
Yeah. In fact, since we had a very tight schedule to be sure that the application will be presentable and usable for the conference, we just added subtitles in English for the videos and for the introduction material. But we can imagine adding different languages and complete also translating the text, the caption on the buttons, and complete translation in other languages. Yeah, welcome.
Yeah, yeah, over there, please.
Yeah, I would like to ask, this also relates to the previous presentation, about 36% of the population have poor or no stereo vision. So then they sort of will not be able to benefit from the virtual reality. So do you test your students before using this? And what do you do with the students who don't have a stereo vision?
Yeah, the test with students is going to be done the next academic year, starting in September. But I want to mention and acknowledge the contribution of 2 of our international students who contributed in the design of the application and the production of the learning material. I must mention also that in the PEGGHy project, there is a part that is dealing with the post-production and monitoring the use of the application and evaluating the contribution to the learning outcomes of the use of the application in learning activities. So we're really planning to rely on the feedback from the users, the students, and also the faculty members in order to improve the application in the future.
Yeah, it's not about application, it's people's brains. If they don't have stereo vision, how they can benefit from the application?
They go on YouTube.
In fact, the time for virtual reality is very short. We worked with specialists that are used with these problematic, and we will see in practice if we encounter some problems, we will try to deal with.
We were quite impressed by the 5.2 million devoted to the project, even if spread within 17 universities. Any idea about the digital part of the story, which I'm understanding is taking videos and coding?
Yeah.
Any idea about how much the chunk of 5.2 million is going to the digital part of the story?
Oh.
I think that you are recruiting an external company, right? You are a professional company that does it.
Really, I'm not able to give you any information about the funding, use, and distribution. What we had here, we didn't get money directly from the project. What we get was the support from a very professional team. Some of them are here. Claire participated in shooting. Yeah, I don't know, but I really didn't have any information about the use of the funding.
Okay, thank you very much. So now we are moving on to the final presentation. Thank you. It's PEGGHy, a platform for experimental geophysics, geotechnics, and hydrogeology of the Graduate School of Geological Engineering at Nancy, France, by Sausse, Cupillard, Abdallah, Géraud, Diraison, Oltean, Golfier, and Cuisinier.
So hello everybody, so it's still me. I introduced this congress and I finished the congress. So I am the director of the school, and just let me introduce our beautiful pedagogical team at the school, because we have a lot of authors on this paper, but this is a very collaborative work. So I'm going to not to speak to virtual reality, but about real reality, please, because the platform I will present you is just 100 meters beside this building, so it's on the site. So this platform, do I not go on this slide because you have done over the information. So what is important for our school, whatever the majors, so Adele speak about the geotechnics major, we have 6 majors at the school. Whatever the topics, we have in mind to put our students on field experience. They passed around 7 weeks on the field, acquiring data, interpreting data, modeling data, and it is very important for the profile of a future engineer, because I like to say that behind the big data application, they know what is the data and the natural data, and it's very important for us. But the problem with the field surveys, we do not manage, control the structure of the underground. So this is an indirect observation of the ground. So we decide to try to help us to teach the field approach using a specific platform. So I present you our PEGGHy platform. The PEGGHy is for platform for experimental geophysics, geotechnics, and hydrogeology. So if you look at this platform, maybe I just have to start the video. Okay, we excavated a pit. you see that this is 60 meters long, 20 meters wide, and 4 meters deep. And we totally excavated this zone and then filled it again with a lot of aggregates. And you see that we have different types of materials. So we have carbonate, we have siliceous sands, we have pebbles, we have basaltic trap, gravels, we have clays, and we have structured a sort of mini sedimentary basin. You see a fault, a mini fault, you see a mini aquifer, a confined aquifer in this zone, in the sand zone. And why I speak about confined aquifer? Because we have put in the pit, you see a geomembrane and a geopentinity complex to try to have a sort of confined aquifer. So you see blocks, okay, with different types of materials, and these materials are used to try to interpret what happens on the field. So you see just here for information, data, and you see that all the blocks of the platform correspond to a high volume, final high volume, because we have 4,600 cubic meter in the pit, okay? And we have property, petrophysical properties, porosity, permeability, density, etc., etc. So we have a fully controlled environment. And moreover, you see that we have equipped the platform with optic fibers. We have two types of optic fibers in the pit. We have strain and temperature sensing fibers on the bottom part of the pit, and at the surface, 15 centimeters deep, we have distributed sensing acoustic fibers to make experiments, and we have perspective to geothermy and geothermal application with this pit, so this is the reason why we use temperature optic fibers. We have always materials, optic fibers, but I just want to show you that we have two digital twin of this platform. We have made a photogrammetric drone survey. You see the flight and the drone, and this survey allows us to have a very, very precise 3D modeling. You see here the raster, you see the zone of the reservoir, okay, in the platform, and we have a perfect model defined with a mesh resolution around the centimeter. So here, this is pixel, this is the raster, and you see the volume, the blocks, all is perfectly defined with this precision. So what for this platform? To try to teach to our students that experimental data are characterized by uncertainty, okay, errors, etc. And here you see classical but fundamental tests in geotechnics that we can perform on the platform. But we can have data, experimental data, and then compare this data to the ground structure that we perfectly know. So this is a unique occasion to try to share and compare things from experimental to model data. This is an example of what we have at the school to teach the basic of geotechnics for our students. But we have some applications concerning geophysical surveys, and I give you here two examples. You see a GPR, you see a GPR here, 3D modeling. So you see here the section of the GPR, and you see that we can detect quasi perfectly the water table in the reservoir. So this is very important. All is constrained by the numerical twin, okay? And the other example I will show you, this is this electric resistive tomography. Here you see that this section, again, is not characterized by the same resolution by the GPR. This is the interest of such type of different types of method, because we can discuss the resolution, the penetration, the uncertainties of each tools, and you maybe remember that we have the little fault here. Excuse me, I lost the, so, well, I take my hand. So you see here the little fault. You see that you have two types of compartment. So I'll try again. Yeah, the little fault is here. You see that this block is different than this block. This is linked to the clay content that attenuates the wave, the electric wave, etc., etc. So we can image the pits precisely, and then the discussion is to what is the best methodology to approach such type of underground structures, and it allows the student to choose this tool versus this other one, etc. So to conclude, what is the interest of such type of pit? The final objective of geophysical, geotechnic, and hydrology application is to model the ground. So we want to teach to our students to define the ground model, okay? And what is the ground model definition? But they need to understand the construction of 3D reliable geological but geotechnical models. We need to play with data. We play with the resolution, the penetration, the different types of data, the scales, okay? And finally, have in mind all the assumptions to do, the uncertainty when entering a model, okay? So here we have a perfect tool to try to teach our students, and we have a controlled geological environment for experiments, I insist on it, versus modeling. And the last sentence I could say to you is, you are welcome on our pit, and we are waiting for you to play with us on PEGGHy. Okay, thank you very much.
Thank you very much indeed. Is there any question for this presentation?
What might become a theme that I live in the wrong country. How much money does it cost to build that?
500,000 euros.
500,000?
Yeah.
Okay, so if you were to do this in Australia, I think you'll have to multiply by a few. Yeah. Okay, thank you.
Okay, any additional question? No more questions? Okay.
It is a free access platform for all academics, so you are welcome.
Okay, thank you. Thank you very much. Now it's time to close the session. I want to thank all the presenters, and also I want to thank you very much for attending the session.